Hey everyone, it's David Townsend from the Net Academy. Welcome to this video, this continuation of the OSPF Open Shortest Path First Routing Protocol. And what I'm going to be going through in this video is how to troubleshoot OSPF on the VMX or virtual MX routers on Juniper Junos devices. And you will see in this lab quite a few different VMX routers, and each one of those VMX routers has got a specific misconfiguration or even a few misconfigurations on that same virtual router. And we're going to go through how that actually impacts or impedes, prevents, stops that neighborship from forming between two or more OSPF speaking routers. So let's get going. And here is the lab that we're going to be using for this video on troubleshooting OSPF. Now, as you can see, it is a bit more of an interesting network. We've got this multi-access switch, which is really just providing a broadcast network between all these different routers. And here we've got router R1, R2, R3, R4, 5, 6, 7 and 8. And you can see for each one we've got a router ID. So R1 has a router ID of 1.1.1.1. R2 has a router ID of 2.2.2.2, and so on and so forth for R3, R4, all the way around to R8. Also, just for your reference, every interface out of these routers is using the GigE 000 interface, specifically the unit 0 as well. In Cisco, you'd be calling that the sub interface, exactly the same thing. And the area for this OSPF network is area 1. That's obviously very important. And what you can also see here are the OSPF adjacency states. Now, if you don't know what these are, check out the description box. I made a video, a quite in-depth video about those OSPF adjacency states and transitioning from one state to another, this specific OSPF hello packets, etc. So check that out if you want to know more. But just very quickly, the down state. Now, this is where you do not want any OSPF router to actually be, because in this state it is saying not the interface is down, but the neighborship is down, the adjacency is down. So that's obviously not desirable. But when you enable and commit an OSPF configuration out of an interface, so in this case it's going to be GigE 000, we transition to the init state or initialization state. What this does is it allows the OSPF router to send out hello packets out of the interface to all other routers in the same area. And they are also waiting for an OSPF hello packet to be received. So they send an OSPF packet, and when they receive an OSPF hello packet from a neighbor, they transition to the two-way state. Now, in the two-way state, you do the election, it's done automatically, of that designated router and that backup designated router. So right here in this area where we've got a multi-access broadcast network, we are going to need a designated router and maybe a backup designated router. The routers which are neither a DR or BDR would be a DR other or druther. They are not a designated router or backup designated router. And as such, the DR others or druthers only form a two-way adjacency to other druthers. They will form a full adjacency to that DR and BDR, but to each other they only form that two-way. Again, if you don't know what the DR and BDR is and how to configure that on Juniper Junos, check out the description box. There's a link to a video I made on the DR BDR setup on Juniper Junos. But when the election is done, if we then transition to the exchange and exchange start, oh, there's a spelling mistake here, I'll actually correct that. What this does is it allows the routers to exchange DBDs or database description. So what they're doing here is they're just saying to each other, I've got this link state database, I've got these contents in my link state database, I've got these contents in my links database, and they're basically detecting, identifying, do I have any missing entries, prefixes, networks in my link state database? And once they've identified that, they then move to the loading state where they send link state requests to the neighbor saying, give me this missing content, give me that missing prefix. My link state database isn't full, isn't intact, isn't complete. So they will send link state updates, link state request, followed by link state update. And when that router receives that update, it's then going to acknowledge back via the link state acknowledgement saying, yeah, I've got that, that's great. And when the link state database is full, guess what? we transition into the full state. So we certainly don't want to be here. Ideally we want to be here, or if it's DR other or druther connectivity to another druther in a broadcast multi-access network, we are only going to get to that two-way state. But first, let's actually go on to router R1. Now, the underlying IP connectivity is almost there. I'm not going to say 100% it is there because, as I said, this is troubleshooting. I have configured deliberately misconfigurations on R2, R3, R4, 5, 6, R7 and R8. So a lot of the show commands we're going to be doing is actually on R1 itself. There's nothing misconfigured on R1. So that's the network, and the IP connectivity is almost there. When I say almost, obviously I've configured some misconfigurations, of course deliberately, for us to troubleshoot and identify how to troubleshoot OSPF and how misconfigurations can actually impede, prevent, stop that OSPF adjacency. But just to prove that some connectivity is there, if I do a run ping 192.168.1. Let's just do 3, just for example. So this is R3's Gigi 000 interface. You can see we've got connectivity to R3, and I can assure you it will be the same for most, not all, but most of these routers themselves. But R1 is not configured for OSPF. If I actually do show protocols OSPF, you can see there's nothing there. So this is the first thing that we need to do. The IP connectivity is there at layer 3, but the protocol itself is not configured. So to do this, I'm just going to do quickly set protocols OSPF. We need to use area 1, and I need to point it out of the Gigi 0000 interface. Okay, and note I'm also doing the .0. This is the .unit, or Cisco world they call it sub interface, same thing, interface. Okay, what this basically does is it allows Junos to define a specific sub interface or unit on that physical interface itself to send out those OSPF packets and to build that adjacency. Now if you don't define it, if I actually enter here, so if I take out the unit and now do that same command again, show protocols OSPF, you can see it's actually automatically populated that .0, where actually I left it out here. Junos will automatically populate that for you. So that is the first point. If you are using on your interface a .3, .100, .200 and you don't reference it here, Junos will automatically enter in .0. So a little troubleshooting tip for you. So that configuration has just been committed into that running configuration on R1. So we should now have OSPF adjacency to R2, R3, R4, etc. all round to R8. We know that's not going to be the case because I've broken this network. But just to prove that, if I do a run show OSPF neighbor, you can see it's only seeing R5. I can see the 192.168.1.5 out of my Gigi 000 interface, and R5 has this router ID of 5.5.5.5. So there's something really not right here. Now there is a command that you can use in Junos, and this is great for troubleshooting. Highly recommend this. If we do a run show OSPF statistics, and then if I do a pipe, I've got 2 different keyboards. I can never remember where the pipe is on the keyboard I mostly use. And if we do find errors, then you can actually see right here that we have got 15 area mismatches. So immediately there, we can identify that one of these routers out here has an area mismatch. Big point for you is, and we'll come on to this later, the areas have to be the same on those routers if they're in the same area. So you can't have one, unless it's an ABR, you can't have one normal router in an OSPF area configured to be in area 1 and the other router in that same area configured to be in area 100. It's just simply not going to work. But this command is great, and if there are any other errors out there, it would say what those errors actually are. I don't want to give too much away. It's obviously not going to tell you where that misconfiguration is and what router that's on, but it's certainly going to give you a very good indication of what's wrong in your network in the actual first place. So you've got this command which allows you to quickly see what misconfigurations, i.e. errors, there are in that specific OSPF network itself. But what you have in the Juniper Junos world is trace options. This is the same in the Cisco world as doing a debug. You simply create a file, say how many files you want, what is the size of those files, and then you give a flag to actually show and indicate what do you actually want to look out for. So if we actually do a set protocols OSPF trace options, i.e. debug in the Cisco world. We then give it a file name, so I'm just going to call it OSPF log. Oh, and I forgot the file, so let's do file OSPF log and do question mark. You can now see I want to give files 3, so there's going to be 3 files and each one is going to be 5 megabytes. And if I do show protocols OSPF again, you can now see I have got this configured. But, and here it is actually here, trace options, file OSPF, size 5 megabytes, 3 files each. However, we haven't defined the flags. The flags allows you to define in that trace options what you want to look out for. So if we do set file, set OSPF trace options and do question mark, you can now see we've got that flag command. So if I do flag question mark, and you can see there's a lot here that you can actually look out for. So if we actually just do hello packets, just for example, hello packets, and enter this and then put this into the running configuration, and now that it's actually been committed into that running configuration, if I do a run show log OSPF log, so that's the file name, we are then going to get all the output of that trace option. So we can actually see here that we have received a hello packet from 192.168.1.5. It was absorbed, but we're not seeing any other hello packets out there. So we've got 195 here and we've got our IP address here. So that's a great way to do some traditional, of course, really in-depth approach to troubleshooting Junos, but you have to use the right flags and also give the right file size and the amount of files that you actually want. So you can get a lot of information out of here. But of course we're not going to go through trace options. I want to show you from a CLI perspective what is the misconfiguration on each one of these routers. So if I go on router R2 right now, because if I do the run show OSPF neighbor again, you can see there's no 2.2.2.2 here. There's no router R2. It's just simply not being seen. Can I actually ping from R1 the IP address of R2? So if I do run ping 192.168.1.2, and you could see there's something not right here. So let's just do a control C. So that is implying there's something wrong with that IP connectivity. Now let's actually just check the interface on router R1. So if I do show OSPF, not show OSPF, I'll do show interfaces GigE000, and let's just check that I've got unit 0. That's correct. And it's family iNet, and it's got 192.168.1.1/24. Okay, that looks right looking at the network diagram. So let's go on router R2. Let's log in, and it's going to configure mode. And actually, let's just do quit. And if I do show interfaces ter, so this is going to give a brief outline of the actual interface itself. And let's just do it on that actually. And what we can see straight away is that it's up and down. So this interface itself, that's why we weren't able to ping, is incorrect. So let's actually go into the configuration mode and do show interfaces GigE000, and we could see immediately that it is disabled. This is what we refer to as admins down. So we need to delete not the interface but the disable command off of GigE000. So if I run that same command again, you can now see that has been deleted. What you can also see here is that there is a network misconfiguration. So you can see in terms of IP addressing, we're using here 192.168.1.2. Now that is correct, but we are using a /25. It's a 25-bit subnet mask. R1 is using a 24-bit subnet mask. So they're never ever, without other routers there, which there's only a switch in the middle, which is not doing any type of layer 3 routing, they're never going to see each other as such. You're never going to get any ping. So we need to change that. There's a great command that I absolutely love on Junos, and that is rename. This is absolutely superb, and it's so quick, because what I could do now is say rename the GigE000 interface unit 0 family iNet address of 192.168.1.2/25, and I want to rename this to address 192.168.1. Don't forget the dot 1.2/24. And now if I do that show interfaces again, GigE000, you can see one command there. It's taken me from a /25 to a /24. Now that is very quick and easy. If I now just commit that configuration into that running configuration, and it's now committed. So let's now test, do we have IP connectivity? So let's do run ping 192.168.1.1, so that's R1's GIGI 000 interface, and we now have got layer 3 connectivity. Do we have OSPF adjacency though? So if I do a show protocols OSPF, let's make sure that OSPF is actually configured first. We have OSPF configured. Okay, that's good, but do we have the adjacency? So let's do run show OSPF neighbor. We do not. Why is that? That is because this is the other misconfiguration. In the OSPF protocol, yes, it's the right area, area 1, but the interface is looking at a GIGI 000, which is correct, but it's looking at the .2, the unit 2, whereas we know if I do a show interfaces GIGI 00, it's using unit 0. So there is a mismatch here. OSPF is looking for unit 2 with the IP address, but that IP address is configured on unit 0. So even though the IP connectivity is there at layer 3, OSPF is misconfigured for that wrong unit. So what we need to do is we need to rename this. So if I do rename protocols OSPF area 1 interface GIGI 000.2, and I want to rename this to interface GIGI 000.0, and now if I do show protocols OSPF, and there we go. That command is so helpful, because now you can see with that one command, instead of deleting it and then doing that set command again, just in one command, much quicker, we've gone from a .2 to a .0. So let's commit this configuration. So that command has now committed. So let's now see if we've got that OSPF adjacency. So let's do run show OSPF neighbor, and we can now see it is still going through the process, but it's now in the X start state. That's absolutely fine. We can see the dead interval is counting down from 40 seconds. That's the default, to 0. And if I do that same command again, you're going to see it's now at 39. But it is eventually going to go to that full state. If I do a run show OSPF interface, here's another command you can use. You can see that it is set to be a DR other out of the GIGI 00 interface, and it's got 2 adjacencies, or building 2 adjacencies out of this interface. So R2 is very much up and working as such. It's not in the full state just yet. It will obviously get there, but that is the first troubleshooting tips that you need to be aware of. First is that great command show OSPF statistics pipe find errors. It will show you what those errors are that it is seeing for the OSPF configuration, area mismatch and other mismatches. I don't want to give it away just yet. Also remember the trace options, defining a file, the file size, how many files you want, and saying what flags you want to look out for. But in terms of the connectivity, as we can see, and this is regardless of the protocol, you need to be having the right subnet mask, the right IP address. You are going to discover that very quickly in the very early stages if you do not have layer 3 connectivity, as we saw. But coming back to OSPF, in Junos, you have to define the correct interface on that unit on that interface in the OSPF protocol. So as we saw, it was configured to the GIGI 000.2, whereas the interface was GIGI 000.0. So there was a mismatch there. And of course the port itself was admin down. It was disabled. All of that would prevent layer 3 connectivity and prevent that OSPF adjacency from building in the first place. And as we can see now, it has gone to a full adjacency between router R1 and R2. So this is R1's visibility running the show OSPF neighbor in monitoring mode. It has got full adjacency to router R2. It did take longer than I thought, but that is just the glorious nature of having a virtual environment sometimes. Never mind, we can still run with it. It's still good training. So what is the issue with R3? And again, if I run that command that I done a while ago, it's no longer there, but if I just to refresh, show OSPF statistics, and let's do that pipe on my other laptop, and let's do find errors, then we could see that there are still 204 area mismatches. Obviously that's going to increment, it's going to increase over time. Now this is the actual problem with router R3. I'm giving you a spoiler, a huge spoiler, I know, but if I actually go onto router R3 and do CLI, just logging in, configure and do show protocols OSPF, we can see, there's actually two misconfigurations here, that it is configured to be in area 2. We know this is in area 1, so that is never ever going to work. So what we need to do from the configuration mode is again use that really handy rename command. So let's do rename protocols OSPF area 2 to area 1, and let's now do show protocols OSPF. And there you go. That is great, because you think that I would then have to enter in the stub, the interface to the priority and whatever else. It's just immediately renamed the area from area 2 to area 1. So let's run that configuration, and it's run. It is completed. So do we have, let's go back to router R1, do we have the adjacency from R1 to R3? Let's do monitoring mode, show OSPF neighbor. We do not see at all router R3. We see R7, we see R2, full adjacency to there. We can see it's trying to get adjacency to R5, but there's certainly nothing out of R3. If I do show OSPF interface, gigi 000, then there's nothing there. I should have done the sub interface actually. So if I do that again, we can see that it's got 3 neighbors, but no real number 4. This should be saying 4. So R3 is not being identified. Why is that? I can tell you right now, the other thing that has to match is that type of network. In OSPF there are different area types. You've got stub, totally stubby, not so stubby area, and totally not so stubby area. And then you've got the normal generic network, which is what we're doing right now. That is area 1. If you don't know what these area types are, again, in the description blocks there is a video, link to a video I've done on these different types of areas. Check it out. It's very informative, very in-depth as well, on how to configure that on Juniper Junos. But coming back to this troubleshooting, this router here, VMX3 R3, is configured to be a stub. But if I actually do show OSPF overview, we can see here that we're area 1, R1 in area 1 is configured not to be a stub. In that hello packet you have flags which identify, is that router an ABR, is it an ASBR, is it a stub, and a lot more. R3 is advertising out in that hello packet, I am a stub network, whereas R1 is advertising out in that hello packet, I am not a stub network. And as such, that adjacency is never ever going to be formed. So that is something else that has to match to form that OSPF adjacency. So coming back to area R3, we have identified that yes, the areas have to match, but also the area type. You've got to have them all configured to be a stub, not so stubby, or NSSA, totally NSSA, etc. That flag has to be identical, has to match for all routers in that same area. So what we're going to do is we're actually going to delete protocols OSPF area 1 stub. And let's do show protocols OSPF. Let's make sure it's gone. Run that configuration. And that is now committed into that running configuration. Now just from here, if I do the run show OSPF neighbor, we can see it is now seeing router R1. So in R3, it's already got that full adjacency very quickly to router R1. And if I come back to R1 and do that same command on the actual interface itself, we can see it's now incremented. You could just about see it here, from 3 neighbors out of the Gigi 00 interface to 4 neighbors. But who are they? If I do show OSPF neighbor, we can now see we've got the full adjacency to router R2, and we've got that full adjacency to router R3. So that's what was wrong with R3. And to recap, the area has to be the same and the area type. So let's move on to router R4 and see what is the misconfiguration from there. Because again, if I do from router R1, let me just go back to R1 here, do show OSPF neighbor, we can see we've got the full state to R2 and R3. Yeah, it's trying to get there between R7 and R5, but there's no R4, just like we saw with the other routers. So let's jump onto router R4. Now I'm already in the configuration mode, so let's just quickly do that show protocols OSPF. And we could see here that yes, the interface is correct. So it's pointing out a gigi 000 unit 0. We are using the right area, area 1. This is not a stub. This is not a totally stubby. So there's no area type on here. Do we actually have the IP connectivity? So let's do run ping 192.168.1.1. And we do have connectivity from R4 to R1. So what is the problem here? The problem, as you can no doubt see, is these timers. OSPF uses specific timers or intervals. We've got the hello interval and the dead interval. The hello interval is by default 10 seconds. What the hello interval is it means that every 10 seconds there is going to be an OSPF hello packet sent out, and that's basically keeping all the other OSPF neighbors out there in the knowledge that actually I'm still here, I'm still present, I'm still active, and let's keep the adjacency up and running, i.e. in the full state ideally. The dead interval is if a OSPF router does not hear an OSPF hello packet within the default value of 40 seconds, it will tear that adjacency down. So it might go from the full state all the way down to down. Now with OSPF, just like area and the area type, what also has to match for all routers in that same area are the hello interval and the dead interval. Now you can see here that on R4 it is configured to have an hello interval of 15 seconds and a dead interval of 60 seconds. Now that in itself is going to be different from R1. And to prove that point, if I actually go onto router R1 and do the run, oh not run, I'm already in monitoring mode, I keep doing that, show OSPF interface gigi 000.0 unit 0, and I want to see the detail on here. We can see that the hello is set on router R1 and it's the same for R2 and R3 because we didn't see that misconfiguration there, but the hello interval is set to 10 seconds. The dead interval is set to 40 seconds. Those are the default values, but on R4 it is configured to have 15 seconds for the hello and 60 seconds for the dead interval. So the 60 seconds is actually 4 times the amount of the hello interval, and it's actually the same on R1. The dead interval 40 seconds is 4 times the amount of that hello interval. But this needs to be amended. So if I actually do delete protocols OSPF area 1, and let's do on the interface gigi 000.0, let's delete the hello interval. Let's also then delete the dead interval. And let's do show protocols OSPF once again, and it's now deleted. If I run that configuration into that running configuration via the commit button, and so it's now committed. If I now go back to R1 and let's see if we've got that adjacency built to R4. Show protocols, okay, show OSPF neighbors, and we can now see R4 right at the top here. So out of the gigi 00 interface, I am seeing IP address 192.168.1.4. It has the router ID of 4444, that is R4, and it is already in the full state. So in recap, on R4, the hello and dead interval was different. That hello and dead interval has to be the same, just like area and area type, for all areas in that same area. So let's move on to R5 now and see what is the misconfiguration on router R5. And what we can actually see immediately is that all this time R1 and R5 have been trying to build an adjacency. If I was to scroll all the way back up to the top on the logs on R1, we'll see that 192.168.1.5, i.e. R5 with this router ID, it's been initializing. This is trying to build the adjacency, but it's not fully getting there. We know that there's not a misconfiguration on R1. So let's go on to router R5 and let's do CLI and let's do the show OSPF interface gigi000.0, and we can see just here that it's point to point. There we go. Here is immediately the network misconfiguration just by using this quick and easy command. I could have done detail, but it's going to give me a lot more information. All of it is very useful. It's not a stub, it's got this MTU 1500, there's no authentication, and the type is point to point, but you can see this up here. So this was just a bit more of a brief overview, a bit of a quicker way just to identify. But here we can see that the interface on the Gigi000 on router R5 is set to point to point. What is it set to on router R1? So let's do show OSPF interface Gigi000.0, and we can see that it's not set to point or point to multi-point. It is completely different. So this is point to point, whereas here we're saying this is DR saying I am a designated router, so R1 is actually a designated router, but it's saying this is a multi-access broadcast network. As we can see here, this switch is connecting all these routers together. It's a broadcast multi-access network. It is not point to point. That is another thing that has to match on OSPF speaking routers. Not only the area and the area type and the hello interval and the dead interval, but also the interface type. There are different types of interfaces that you can define on Junos for the OSPF protocol. So let's go to router R5 and go into the glorious configure mode, and let's do edit protocols OSPF. And I always forget that. And let's do show so we could see the configuration, and here we could see it's configured to be interface type point to point. Now I could delete this, so I'm just going to quickly delete area 1 interface Gigi00 interface type point to point. Actually, if I do the question mark here, that's what I wanted to show. You could see here all the different types of interfaces. So point to point here is when you say it's not a broadcast on even a multi-access network, it's point to point. Two routers which are connected on that same link. You might have a network in between, but that is a point-to-point network. We then have point to multi-point, kind of like a hub and spoke, and then we have a non-broadcast multi-access network. So depending on the type of interface, you might not be using that multicast IP address of 224.0.0.5, maybe .6, if you have a DR and BDR in a broadcast multi-access network like we've got here in area 1. For point to point, you have to define that neighbor specifically on the CLI. You have to define that neighbor's IP address to build that adjacency. But here R5 is saying, well, I'm point to point. R1 is saying I'm a broadcast multi-access network, and as such R1 is using the 224.0.0.5 and .6 IP addressing, sending out and receiving all the LSUs, etc., whereas R5 is still waiting for that neighbor command, which obviously it's not here because we have to manually define it, and that's why it's trying to build that adjacency, but it's not really fully getting there. But if we actually just delete this command right now and do show protocols, actually it's just do show because it's right there, and you can see it is now deleted. And if I commit this configuration, and with the configuration now committed, if I now do a run show OSPF neighbor, let's actually see have we got to that full state, and you can see immediately router R1 1.1.1.1 R5 has got that full state to R1. It's also got a full state to router R2 2.2.2.2, but it's two-way to R3, two-way to R7, and two-way to R4. That's something else that we actually need to look into. So let's move on to router R6, but before we actually do so, let's do a quick recap on what we have seen so far for all these routers from R2 round to R5. As we saw on router R2, there was quite a lot of misconfigurations on that interface itself. The interface was disabled. Of course, regardless of the protocol or even the layer, if that interface is disabled, it's not going to work, is it? So that was the first thing. Also, the part that has to match for all OSPF routers in the same area is they have to be in the same subnet. R2 was configured to be in a .25, but all other routers are configured to be in a .24-bit subnet mask or /24. The sub networks have to match. But as we also saw on R2, even though the Gigi000 interface was configured to use unit 0, the protocol's OSPF was configured to point to GigE 000 but unit 2. So the OSPF protocol on Junos has to point to that right interface with that right IP address and the right subnet mask on the configuration itself. Moving on to R3, what did we see on router R3? We saw two big points that were mismatching. First was the area number. R3 was configured to be in area 2. All other routers are in area 1. The area has to match, but also the area type. R3 was configured to be in a stub network. This is not a stub network, it's a normal type of OSPF network. So again, the area type as well as the area has to match. On router R4, we saw that actually the hello and dead intervals were completely different. The default values is hello interval is 10 seconds, dead interval is 40 seconds. R4 did not have that, and as such the adjacency was not building. It wasn't even getting to the initialization state. Unlike R5, it was getting to the initialization state because it was trying to build that adjacency, because it had the interface configured to be point to point. But this is a broadcast multi-access network, so it's trying to get there, but all other routers, and especially R1, were saying, I'm not a point to point, I'm not defining manually this neighbor IP address. So R5 was trying to get there, but no other router out there was configured to accept that configuration. So the interface type also has to match. Let's move on to router R6. What is the network misconfiguration that I've done on router R6? Do we first have connectivity? So if I do ping 192.168.1.6, we can see that we do have layer 3 connectivity to router R6. That is of course very good. Now on moving over to router R6, let's do a show OSPF overview. There we go. So we could see here that the router ID is 6.6.6. That is correct. We can see that it is not a stub network. We can see we're using the right type of area, i.e. area 1. But we can also see, SPF runs, etc. There's no ASBRs or autonomous system border routers. So everything here actually looks fine. What about on the interface itself? So let's do show OSPF interface GigE 000.0. Let's do detail. What we can actually see here is out of GigE 000, I am a DR other, area 1, I can't see a designated router, no neighbors because there's no adjacency right now, otherwise this would show R1 as that designated router. The hello timer and the dead interval is correct as the default values, but look here, authorization type password. OSPF can enable a certain level of security on the interface itself, like MD5 simple password, or God forbid, don't do this please, none. It's completely insecure. Here we're actually doing a simple password. So what that means is it's not hashed. So if you used to use some kind of Wireshark capturing tool, you'd very quickly be able to see what that password actually is. It's just sent in plain text. However, that is the actual issue. We have authentication on R6's GigE 000 interface. But if I go on to router R1 and run that same command, so let's do show OSPF interface GigE 000.0 detail, we could see that there's no authentication here. So R6 is trying to say, well, I want security here, and that's obviously a good thing. So I'm actually going to reconfigure every router here to have that connectivity with security. So what have we got configured? So let's go into configure mode. Let's see what we've actually configured here. Let's do show protocols OSPF area 1, and we can see here it is authentication, simple password, it is secret data, the password is Juniper, and now I'm just going to reconfigure that on all other routers. So if I go on to router R1 and do configure, and let's do set protocols OSPF area 1 interface GigE 000.0, and let's do question mark, and I want to apply authentication question mark, just so you could see you've got simple password. None would be just don't even do the authentication command, or we could do MD5, so it's a certain hashing. So we want to do simple password because that's what R6 is configured to. And now we actually enter in the password itself. So here we go, Juniper. Now I'm going to copy that command and paste it onto all other routers. And so I've done the command on router R1. I've just done it on R2. Let's do a quick commit. Let's go on router R3 and do a quick commit. After doing the copy and paste, R4 commit and R5. Hey, that's not what I wanted. That's doing something else. So let's just do quick. It's because I'm here. So let's do top and let's do set. There we go. And let's do commits there. And now look at this. How beautiful is this? We have got full state to router R2. We have got the full state to router R3, the full state to router R4, the full state to router R5, and the full state to router R6. But we are now, if I do show OSPF interface, gigi000.0 detail, we are now applying a certain level of security, i.e. authentication type password, with that password of Juniper. But again, depending on your network, I'd recommend MD5 for security reasons. So let's move on to router R7 now. Now, as we can see, if I do the show OSPF neighbor, then we can see R7 is here. I've just enabled it, good old virtual environments, but we can see router ID 7.7.7. I think that's 4 sevens, and it is router R7 and it's in the exchange state, and it seems to be hanging here. No matter how many times I do this, it never really gets to that full state. It's just in exchange. Now there's one misconfiguration which has to match. This configuration has to match on all OSPF routers in the same area, but if it's misconfigured, it will actually cause this effect where it just seems to hang in the exchange state. Obviously, I'm not going to say that just yet, but what I will do is just do show interfaces gigi000.0 and just do detail. So, I done the interface itself. I didn't do show OSPF interface. There we go, a bit different. Gigi000.0. And let's do detail on here. I got there eventually, but we can see the right interface. We can see it's DR for area 1. The backup designated router is router R2, 6 neighbors, adjacency count of 5, and yeah, we got the password, etc. But what I can also see is the MTU of 1500. So let's go on to router R7 and run that same command. So let's do show OSPF interface gigi000.0 or unit 0, and let's see the detail here and actually see where is this wrong, what is misconfigured. So we have the right interface. We can see we are in area 1. The DR is, or the designated router is R1. R2 is the backup designated router. It can see all the other routers out there, and if I actually do a show OSPF neighbor, we can actually see it's already got the two-way connectivity to router R3, R4, R5, R6, and even no, not R8 yet, but we can see that routers R1 and R2, both of them are in the X start state. So R1 is saying that, you know, it's in the exchange state. If it's all the way back up here, you can see it's an exchange, but R7 is saying, well, actually I'm in the X start state. So those are the two states here. One saying I'm trying to exchange DBDs, database descriptions. The other router, and I need to change it, it still says that spelling mistake, so I will change it in just a second. It's saying, well, I have this configuration, I'm ready to start exchanging DBDs before going into loading. The actual network misconfiguration is right here, MTU 1480. So on R7 it's configured to have 1480 bytes, 1480 bytes, but on the R1 and all other routers it is using the default value for the maximum transmission unit of 1500 bytes. That is another thing that has to be matching on all OSPF routers in the same area is the MTU. There we go, I changed it so we now have the right spelling, which is great, of course. So, as I was saying, when you've got one router with a higher or bigger value for an MTU, it is going to go, as we saw with R1, it's going to go into the exchange state. I want to start exchanging my database descriptions for you, but those packets are going to be of a specific length, aren't they? But R7 is saying, well, my MTU is actually smaller than yours, and as such, I'm only going to go into the Xstart state. So you have one that's one step ahead saying, well, I'm ready to receive, but my MTU is smaller than yours. And then you have the other router saying, well, I'm ready to send, but my MTU is bigger than yours. And so they just create this process of saying, well, send me what you've got, but I can't receive it anyway. So the MTUs have to match, otherwise you get this sort of like overlap between different routers in that same area, going between the exchange and the exchange start. So this is what needs to be changed on router R7. So if we go into configure mode and do show protocols OSPF, and we can actually see here I've already done the password, otherwise you wouldn't see any connectivity there, but we can see this MTU of 1480. So let's delete protocols OSPF Area 1 interface gigi000.0 MTU, and let's do that same command again, show protocols OSPF. It is removed, it's run that configuration into the running config via the commit function, and we can now see it is committed. So if I do quit, or I could have done commit and quit, so let's do show OSPF neighbor. We have now got that full adjacency to routers R2, which is the BDR, and to R1, which is the designated router. So 4 adjacencies to both routers, but to all other routers we have got two-way adjacency. So last but certainly not least, let's move on to router R8. Now before we troubleshoot this, let's actually see if we've got connectivity to R8. Let's do ping 192.168.1.8. We do have layer 3 connectivity there, but can we actually see from an OSPF point of view an adjacency to R8? So let's do show OSPF neighbor, and we simply do not. We've got full adjacency to everything else, all other routers out there, but not to R8. So let's go into R8. Let's do a show OSPF interface gigi000.0, and we can see it looks okay in terms of it's the right interface, it's the right area, but there's no neighbors. It's just not seeing anything here. Let's do a show OSPF detail overview. And what we can see here is, yet again, it's the area number 1. It's not a stub network. We don't see any ABRs. There's nothing really here that's indicating why the OSPF adjacency is not being built. Let's now try show OSPF statistics. Let's actually see if I'm sending or receiving anything. That in itself is a big cause of concern, because we are not sending any hello packets and we are not receiving any hello packets. So what could be possibly causing R8 not to send any hello packets out of this interface, but also not to receive any packets out of this interface? But we know that the layer 3 connectivity is actually there. So if we go into configure mode and do show protocols OSPF, this is the problem. We have configured, or I've configured I should say, the interface to be passive. What that means is that if R8 was configured to be an ABR and connected to area 0, because you wouldn't be able to connect to another area unless you want to do a virtual tunnel, which we're not covering right now. But if it was connected to area 0 via another interface and it wanted to advertise everything that we're seeing here in area 1 into area 0 but not form any adjacencies, this is what the passive command allows. It allows for R8 to advertise out of the gigi00 interface this whole network here into OSPF area 0, but not to form any adjacencies, not to send out any hello packets, not even to receive any hello packets, because no one else here, no other router knows about R8's actual OSPF existence. So this needs to be deleted. So let's delete protocols OSPF area 1 interface gigi000.0 passive. Let's do the same command again, show protocols OSPF, and let's commit that configuration into the running config. So let's think back to what I showed a few minutes ago. I didn't point it out deliberately, but if we do a run show OSPF overview, then what you can see here is actually the big giveaway. Router ID of 1.1.1.1. It should be 8.8.8.8. Router ID 1.1.1.1 belongs to R1. So this is one thing that cannot match in an OSPF area network, is the router IDs. They absolutely cannot match because the router ID identifies the router itself. If you don't configure the router ID, it will use the IP address on the interface as the ID, or maybe the management IP, depending if you've got that configured. But really in good practice, you use the router ID. So this is what is causing the issue. So this needs to be amended. So let's go and amend that router ID. So let's go into edit, routing options, do show. Let's delete the router ID of 1.1.1.1 and let's now set the router ID of 8.8.8.8. Now let's do a quick show. Looks good. Let's do a commit and quit. I'm actually going to do it this time. But you're probably thinking, hang on Dave, you forgot something. Absolutely, I did. There's been a lot that I've gone through. I'm a human being. I forgot to do the password. So not only was the interface configured to be passive and the router ID was wrong, but I left off the security. So let's do show protocols OSPF. We could see I've not configured the authentication. So let's do set protocols OSPF area 1, whoa, area 1 interface gigi 000.0 authentication, simple password, Juniper. Let's commit that configuration. And now that it's committed, let's do a run show OSPF neighbor. And there we go. We have now got full adjacency to router R1 and router R2, as well as the two-way adjacencies to all other routers out there. Now, my final point that I want to talk about is the priority here. You can see, and you've probably picked up, that on all routers other than R1 and R2, R1's using the default value of 128 in terms of the interface priority. I can set the R2 to have a interface priority of 1, but all other routers have a priority of 0, which means they will never ever be a backup designated router or a designated router. They just simply won't have that connectivity. So even though this is working right here, you need to be aware of that if all routers have a priority of 0, they will always be in the two-way state. So if I just do a run show OSPF neighbor again on router R4, we can see that yes, it's got the full way adjacency to R1 and R2, but to all other routers it's two-way. So if all routers have that priority of 0 on that interface in the same area, they're never going to have that full adjacency. They will forever be stuck in two-way. And so that's the end of this video on troubleshooting OSPF on Juniper Junos devices. We've gone through a lot of information, and even myself, my eyes getting a bit tired, was starting to make a few mistakes towards the end. Thankfully I picked it up. But in summary, what we have to remember is all the things that have to match in an OSPF area to form an adjacency. The area type, the interface type, the MTU, the hello interval, the dead interval, the subnet mask, and as I almost did, the authentication. I left that off R8, quickly saw it, rectified it, and boom, the adjacency was built. But what must not match is the router IDs. You will see confusion if two routers or more have that same router ID. So that is how to troubleshoot OSPF on Juniper Junos devices. If you like this video, please give me a like, please subscribe. I appreciate all you people for following and liking my videos. Feel free to comment on if you like this video or not, and stay tuned for the next video where I'll be going through virtual tunnels. Thanks for watching and goodbye.